Hello, students. Okay, so we are going to quickly review polar graphs, how to graph polar graphs. So recall that polar coordinates are written as r comma theta. Theta is the angle or radian measure from the initial side, which is 0 right here. That is our initial side. Okay, and r is the distance from the origin and direction. And direction meaning if r is positive, then we are going to go in the direction of the given angle or radian measure. If r is negative, then we're going to go opposite our angle or radian measure in the opposite direction. So let's graph one. R is equal to 1 plus 2 sine theta. So this is going to be our polar equation that we're going to work with. Okay. I first like to graph it on x and y axes. That helps me to generate my polar graph. So I'm going to shift this up 1 because this is a vertical shift of 1. And then I have an amplitude of 2 units. So it goes up 2 and down 2. So this is going to be at 3, and this is going to be a -1. So my range is going to be -1 to 3, which therefore means that my r's are also going to range from -1 to 3. And then let's graph this out. So this is pi over 2, pi, 3 pi over 2, and 2 pi. So now if I were to graph this, I would start here. That's my sine graph. Down to here, here, here. If you don't remember your sine graph, then what you should do is stick in all of these x values, which are your thetas as well, into the equation and evaluate. So this is my theta axis. This is my r axis, which I'm graphing this way with my r being my y's and my theta being my x's. So now what I'm going to do is I'm going to look at 0. When theta is 0, my r is equal to 1. So that means that when I'm out 0 radians, I am going to plot my point a distance of 1 from the origin. Now, there's a lot of circles here, so I'm going to make every 2 circles equal to a radius of 1 unit. So now this is 4 circles. That means when I'm out here, that is a radius of 2. And here, 6 circles, and that's going to be radius of 3. I'm just doing that just so it helps me see a little bit clearer because there's a lot of lines there. Okay, so this is a positive 1. So I'm going to go 0 radians, positive 1. Now, when I get to pi over 2, at pi over 2 radians, I'm positive 3. So here's pi over 2 and positive 3. 1, 2, 3. So somehow I traveled from here to here. How do I get there without doing every single one of these? Because that would just be torturous. How do we get there quickly? We just look at the pattern. As I progress from 0 radians to pi over 2 radians, I notice that my r is increasing. The smallest r that I'm going to have is 1, and the largest r that I'm going to have is 3. So I'm just going to sketch this. This is not accurate at all, okay? But the picture is going to look generally the same shape as what we want it to be. So as I progress on each of these, I know this is going to be past 1. It's going to increase, increase, increase. I don't know how fast it's increasing, but it's going to go all the way up to 3. So I'm going to do something like this. All I did was go out, out, out. Each time I went further until I got to 3, because that is what's happening with these. Now, pi over 2 to pi. Well, pi has an r of 1. So when I get to pi, I should know that exact coordinate, and that is 1. And now these r's are decreasing. The largest one is 3, and it's going to decrease down to 1. So I'm going to go, okay, each time I'm going to get less and less and less until I'm down to here. So like so. Okay? And then I still have a little bit more positives. So let's find out what this one is. So I'm going to do a quick equation. 0 is equal to 1 plus 2 sine theta, because that's when r is equal to 0. And so that means sine theta is equal to negative 1/2. And we go, okay, when is sine equal to negative 1/2? That's 7 pi over 6 and 11 pi over 6. So that means this right here is 7 pi over 6, and this right here is 11 pi over 6. So 7 pi over 6 is right there. Until I get to 7 pi over 6, these are decreasing, and each time I plot a point, it's going to be smaller and smaller. They're going to go down to 0. So I plot a point, go out until I get to 0. So it's going to do something like this. Okay? So now, this is the first section of my graph. All of this is the second section. So this is the first section. Then all of this is the second section. Excuse me. Now, from 7 pi over 6 to 3 pi over 2, my r's are increasing. The largest r I'm going to have is a length of 1, but now it's in the negative direction. So, negative is opposite. So, 7 pi over 6, what is opposite 7 pi over 6? Pi over 6. So I am going to be graphing here, and 3 pi over 2, what is opposite of 3 pi over 2? Pi over 2. So I'm going to be graphing in this area. 7 pi over 6 to 3 pi over 2 is right here, but all of them are negative. So all my r's are negative. Therefore, there aren't going to be any points here. They're all going to be plotted on this side, on the opposite side, because all my r's are negative. So when I get to 3 pi over 2, my r is a length of 1. So the opposite of 3 pi over 2 is going to be in this spot, pi over 2, and it's a length of 1. So that would be my point there. So I'm going to increase, little by little until I get to 1. So notice, I was in between pi over 6 to pi over 2. Now, 3 pi over 2 to 11 pi over 6, they are decreasing down to 0. Here's 3 pi over 2. Here's 11 pi over 6. These are all negative. So instead of plotting in this area, we are going to be plotting in the opposite area. Everything opposite. So opposite of 3 pi over 2 is pi over 2, and opposite of 11 pi over 6 is 5 pi over 6. So we're going to be plotting in this area. And so now all my lengths, they start from 1 and they decrease down to 0. So they start at 1 and they decrease down to 0, like so. I'm going to call this 3. Now 11 pi over 6 to 2 pi, they are positive. So that means I'm going to graph 11 pi over 6 to 2 pi. I'm going to graph in this region, and my r's are going to increase from 0 to 1. So here is my 11 pi over 6, and they are going to increase from 0 to 1.